So students, I was telling you the different types of side chains attached to the main chain. To the main chain, if CHO group is attached, then its name is formyl. It is also written like this, C double bond OH, or it can be written as bond line notation C double bond OH. So this formyl can be written like this or like this. This is all formyl only. Then in the main chain there is carbon. This is the carbon atom of the main chain. Carbon atom of the main chain, which is attached to oxygen by a double bond. Then this becomes side chain. This side chain name is oxo. Then in the main chain, if there is carbon but attached to nitrogen and which is attached to H, then it is called imino. Then this is the main chain. Here is a carbon double bond with N attached to OH. So say this is carbon number 3, then prefix is written as 3-oxime, or it is written as like say C double bond N and double bond N is the side chain. Then the side chain name is imino. Then here double bond N and to that N OH is attached, then it is called N is the attachment, therefore N hydroxy imino. Then double bond N attached to R, then it is called N-alkyl imino. Double bond N attached to amine group, then it is called N-amino imino. This is the name of the side chain and this itself is written as the prefix. Then side chain name is OH. Then the side chain name becomes hydroxy. Then O, and in place of H if there is R, then it is called alkoxy. R is alkyl group and this is oxygen, alkoxy. Now suppose this is the main chain. If that R is CH3 group, so CH3 group is called methyl. Methyl along with oxygen is called methoxy. Say this main chain, it is 5th carbon, then the prefix becomes 5-methoxy. Then that CH3 group is also just written as like this. This dot indicates CH3 group, methoxy. Then oxygen, in place of methyl group, if I have this CH3, say this CH3 is also written as Me. So it is, I can write OME. OME is this is also another way of writing methoxy. Then oxygen attached to CH2 attached to CH3. This is ethyl group and this is oxygen. This is called ethoxy. That ethoxy group can be written like this also. But ethyl group also written as Et. So OET. This is called ethoxy. Then O attached to CH2, attached to CH2, attached to CH3, then it is called N-propoxy. N-propoxy, because this is N-propyl group attached to oxygen, N-propoxy. Then this O is attached to again propyl group, but it is called isopropoxy. Isopropoxy. Now here, this is the main chain. It is attached to oxygen, attached to CH2, 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 CH3. Then it is called N-butoxy. So now I am O, CH2, CH3, here CH3, this is again butyl group but isobutyl group, therefore it is isobutoxy. This isobutoxy I can write also as bond, then this CH3 like this. This is bond line notation of isobutoxy. Then O, this is tertiary butyl group, CH3, CH3, CH3 it is. That's why then it is called tertiary butoxy. Tertiary butoxy. Then O, CH2, 1, 2, 3, 4, 5. Then it is called N-pentoxy. O, CH2, 1, 2, 3, 4, 5. This is neopentoxy. O is attached to benzene ring. This is phenyl group, it is oxygen, it is called phenoxy. That phenoxy is also written as OPH, or it is also written as OC6H5. Then this is benzene ring, it is called phenyl group attached to CH2, now it is called benzyl group. This benzyl group attached to the main chain, now prefix becomes benzyl. Now this is the main chain, to that NH2 is attached, then it is called, then the side chain name, or I can say prefix, is written as amino. Now here, in this NH2 group, one hydrogen I am replacing by R, means R is attached to N, then prefix or side chain name becomes N-alkyl amino. So now, if that R is CH3 or methyl group, it is called N-methyl amino. If it is CH2 CH3, then it is called N-ethyl amino. Then that is also written as NH Et. Now, in this NH2, one hydrogen replaced by R, another hydrogen replaced by another alkyl group. Then the side chain name becomes N-alkyl amino. Now to this, one side methyl, one side ethyl is attached, then it is N-ethyl amino. So I will write that as N, this is methyl, this is ethyl, like this also I can write. Now N, this becomes what? N comma N, diethyl amino. NH, like this it is. So it is N isopropyl amino. Then it is N, this side one isopropyl group, this side one isopropyl group, then it becomes N comma N di-isopropyl amino. So like this, these are all the different side chains and their names. So that name of the side chain along with the number of the carbon atom of the main chain is written as the prefix. So now, like this, in the IUPAC name, the first part called prefix we write like this. So behind prefix, so much story is there. After finding out what is prefix, then we have to know what is root word. Because now already I was telling, IUPAC name of the RNA compound, first part is prefix. Prefix indicates the name of the side chain attached to the main chain. Till now, I have given all the possible side chains that can be attached to the main chain. After that, we have to find out what is the root word. Then we have called primary suffix and then secondary suffix. Now coming to this root word indicates the number of carbon atoms. Number of carbon atoms present in the main chain. So I was telling like this, now this is the main chain and these are all side chains I told. Side chain's name already will come in prefix, but this main chain, it has 1, 2, 3, 4, 5, 6, some number of carbon atoms. If this main chain has only one carbon, then the root word is meth. If the main chain has 2 carbons, then root word is eth. If it has 3 carbons, then prop. 4 carbons but, 5 carbons pent, 6 carbons hex, 7 carbons hept, 8 carbons oct, 9 carbons non, 10 carbons dec. Now, if the main chain has 11 carbon atoms, then if 11 carbon atoms are present in the main chain, then the root word is dec. Before that one is there, it is undec. Dec for 10, un for 11, undec. Then 12 are there, dodec. 13 are there, tridec. 14, tetradec. 15, pentadec. 16, hexadec. 17, septadec. 18 carbon atoms are there in the main chain, octadec. 19 carbons are there, nonadec. 20 are there, icos. 21 are there, unicos. 22 are there, doicos, triicos, tetraicos, like that. Finally, in the main chain, if 30 carbons are there, then it is called triacont. Root word here we write as triacont. If the main chain has 30 carbon atoms in it. Okay, so like that, prefix we know, root word we have to know like this. After knowing the root word, then we have to know what is primary suffix now. Now, this primary suffix indicates whether the main chain is saturated or unsaturated. Suppose in the main chain all single bonds are there, then the main chain is said to be saturated main chain. So like this, if all single bonds are there, then this primary suffix for this is written as "an". Now, in the main chain, everywhere single bond is there. If at some place if there is a double bond, then, or at some place if there is a triple bond, then we say that the main chain is unsaturated. Now, somewhere if there is a double bond, then primary suffix will become "in". And this double bond is at what number? Say 1, 2, 3. Then I write 3-in. So primary suffix becomes 3-in. Here 1, 2, 3, 4, 5, 6. So why? Because while giving numbers I already told the functional group should get lowest number. If I give numbers from right to left, this will get 4. That means triple bonded carbon will get the number 4, which is more. But when I give from left to right, triple bonded carbon will get 2. Therefore, this is correct way of numbering. But triple bond is there, then I will write "-". So it is called primer suffix. I write as 2-ine. So primary suffix, if all single bonds are there, primary suffix can be "-ane". If one double bond is there, then "-ene". 2 double bonds are there, "-diene". 3 double bonds are there, "-triene". Then if triple bond is there, "-ine". 2 triple bonds are there, "-diene". 3 triple bonds are there, "-triene". Like that we write the prefix. And we should also write the position of the double bond or triple bond. So like that we'll come to know the prefix. Finally, we should know what is secondary suffix. Now, till now I told that there is CHO group, there is COOH group, CONH2 group, methyl group, ethyl group, like that. Many side chains are there, many functional group are there. If they are treated as side chain, what is their name? If the compound has many functional groups and many side chains, I told among them, one will become the functional group of highest priority. That functional group of highest priority, its name will come in secondary suffix. So secondary suffix indicates the functional group of highest priority. Functional group of highest priority. Suppose some 3 functional groups are there and 4, 5 side chains are there. In those things, one will become the group of highest priority. Its name will come in secondary suffix, and all the remaining functional groups and side chains, their name will come in prefix. Okay, so now for what type of functional group, what is the secondary suffix we take? That we have to learn now. So here what I am doing is functional group, then structure of the functional group, then name of the functional group. Then if so and so functional group is there, then what will be the secondary suffix. Now, if SO3H group is the highest priority group, if SO3H group is the highest priority group and structure of that is written as S double bond O OH. Name of this functional group is sulfonic acid. Now, if this at all is present as the group of highest priority, then secondary suffix is also sulfonic acid. Sulfonic acid is a secondary suffix. Then COOH group is present as a functional group. Then its structure is C double bond OH. Name of the functional group is carboxylic acid. Then secondary suffix is oic acid. Then C double bond O, OR, that is COOR. Then structure is C double bond OR. Name of the functional group is ester. Now here, in this carboxylic acid group, it is written as oic acid as secondary suffix. I write O minus H plus. Here the difference is, in place of this H plus, I have R plus, like this. So, oic acid anion name becomes O8, like say sulfuric, sulfate, nitric, nitrate, oic, O8. So, sulfuric acid anion is sulfate, oic acid anion is O8, O8. So, but cation is R. So, secondary suffix of this part will become ANO8, ENO8, like that. O8. I will see, this is CH3COOH. Its name is ethanoic acid. But here now I am attaching R. Then alkyl ethanoate, like that. Its name becomes what? Alkyl ethanoate. Then, if the functional group is C double bond, if the functional group is COX, then structure is C double bond OX. Then, name of this functional group is acyl halide. Then secondary suffix will be oil halide is the secondary suffix. Oil halide. Then functional group is CONH2. Structure is C double bond O NH2. Its name is, functional group name is amide. Then secondary suffix is also amide. Now functional group is CN. Structure is C triple bond N. Name of the functional group is cyanide. Secondary suffix is nitrile. Secondary suffix is nitrile. Now functional group is CHO. Structure is C double bond O H. Name of the functional group is aldehyde. Then secondary suffix is al. Then functional group is bond CO bond. Structure is C double bond O bond bond. Name of the functional group is ketone. Then secondary suffix is on. Functional group is OH. Structure is bond OH. Then name of the functional group is alcohol. Then secondary suffix is ol. Secondary suffix is ol. After that, now we have functional groups like halogen, NH2, then nitro. Though they are all functional groups, their name will not come in secondary suffix, because while naming these functional groups, they are not treated as functional group, they are treated as side chains only. So, like this, we will come to know secondary suffix. Means secondary suffix indicates the name of the group of highest priority. In the organic compound, many functional groups are there. In that, one having highest priority, its name will come in secondary suffix. So, if these things will become so and so highest priority group, then this will be the secondary suffix. Like this, individually we came to know prefix, we came to know root word, then we came to know primary suffix, then we came to know secondary suffix. Then you combine all these four parts, then you will get IUPAC name of the organic compound. So you will understand more clearly after studying many examples. So now we are going to study so many examples, and based on all these rules that we have learned now, we are going to name them. Okay? So examples will be continued. Dear students, after learning the different rules of writing the names according to IUPAC system, now let us write the names of all these compounds. First one, you see this. This is the longest possible chain, main chain. This is one functional group, this is one functional group. But COH is of high priority. Therefore, high priority functional group should be in the main chain, and it should get lowest number. So therefore, it will be given 1, 2, 3, 4. So main chain is having 4 carbons. Therefore, the root word is bute. And between all the carbon atoms, the bond is single bond, butane. So root word is bute, primary suffix is ane. Then secondary suffix indicates the group of highest priority. The group of highest priority is COH. If COH group is present as high priority group, then secondary suffix is oic acid. So root word, prefix, secondary suffix over. Then prefix. To the third carbon, NH2 group is present. If NH2 group is present, it is called amino. Then it is, prefix is 3, because NH2 group is attached to third carbon, so it is 3-amino butaneoic acid. Now this one, there are no side chains. So this is the main chain. Now it is having 3 carbons, 1, 2, 3. So root word is prop. So between all the carbons, the bond is single bond. Therefore, primary suffix is ane. And the functional group is amide. So propane, if CONH2 is there, secondary suffix is amide. Propane, amide. Then here, there is no side chain. But there is ketone group. This is carboxylic acid group. But in these two, COH group is of highest priority. Therefore, it should be in the main chain. So, main chain has 4, how many carbons? 1, 2, 3, 4. So, root word becomes bute. And here is single bond, single bond, single bond. So, in the main chain, all are single bonds. So, therefore, primary suffix is ane. And COH is present. Therefore, secondary suffix is oic acid. But how should we give numbers? We should give numbers in such a way that this carbon of the functional group should get lowest number because it is of highest priority. Therefore, it is 1, 2, 3, 4. But there is another functional group ketone. But now this, because this is of high priority, this becomes low priority and it is treated as now side chain. So to the main chain there is a double bond with side chain at third carbon. Therefore if C double bond O is there, so I told C double bond O, then prefix is oxo, so 3-oxo butaneoic acid. So now here this is the main chain. This is carbon 1, 2, 3, 4, 5. Main chain has 5 carbons and this is the side chain. So as there are 5 carbons, root word is pent. Root word is pent. Primal suffix is ane. And there is no functional group. Of course, this is a functional group, but it is, I told, amines are always treated as side chains. So therefore, root word is there, primary suffix is there, and for this compound, there will be no secondary suffix. Now, what is the name of this side chain? Now, this side chain is attached to third carbon of the main chain. And to the nitrogen, there is, this is CH3 group. CH3 is methyl. So, N-methyl amino. So, 3. In the bracket, I will write N-methyl amino pentane. 3 N-methyl amino pentane. Then now this one, this chain has 1, 2 carbons, this chain has 1, 2 carbons, but this chain has 1, 2, 3, 4, 5 carbons. This becomes main chain and this becomes side chain. So main chain has how many carbons? 1, 2, 3, 4, 5 carbons. So numbering should be done in such a way that the carbon to which side chain is attached should get lowest number. Therefore, this is 1, this is 2, this is 3, 4, 5. So side chain is attached to second carbon. Then I will put 2, then bracket. Side chain is to this N, this is ethyl group attached, this is ethyl group attached. Therefore, N comma N diethyl. So 2 N comma N diethyl. And N is called amino. So now this total 2 N comma N diethyl amino is the prefix. After prefix, root word. Root word indicates number of carbons present in the main chain. Main chain has 5 carbons. Therefore, root word is pent. Then primary suffix. Primary suffix indicates whether there is single bond or double bond or triple bond in the main chain. In the main chain, all bonds are single bonds. Therefore, primary suffix is ane. And in this, there is no functional group. Therefore, secondary suffix will not be there for this compound. Therefore, total name of the compound is 2 N comma N diethyl amino pentane. Then, let us see this. Now, its common name, it is actually HCOOH. HCOOH. HCOOH common name is formic acid. Formic acid. So now, IUPAC name is what? Here in the total chain there is only 1 carbon and there are no side chains. No side chains means in this compound no side chain, therefore there will be no prefix. Name starts with root word. So main chain has only 1 carbon, therefore root word is meth and primary suffix is ane and COOH group is there. When COOH group is there, secondary suffix is oic acid. So methanoic acid, methanoic acid is the name of this compound. Its common name is formic acid. Then this formic acid, instead of writing like this, I can write simply as HCOOH. It dissociates to give HCOO minus and H plus. So now this is called formic acid. Always the anion name of the acid. See, this is acid, this is its anion. If the acid name ends with ic, the anion name ends with ate. If the acid name ends with us, the anion name ends with ite. It is formic, therefore it will become formate. So this ion name is formate ion. So IUPAC name is, just now I told it is methanoic acid. Therefore this ion name becomes methanoate. Methanoate. So this I will treat like this seventh compound. This is HCOO. HCOO means formate, common name, methanoate, IUPAC name. This is cation name. Suppose if I write this is HCOONA, means HCO minus anion, Na plus cation. So name becomes sodium formate. So in place of sodium I have methyl group. Therefore its name becomes methyl formate. Methyl formate is the common name, not IUPAC name. Because in the IUPAC system formate ion is called methanoate. Therefore IUPAC name becomes methyl methanoate. Now let us see this. See, CH3COOH is acetic acid. Therefore, its anion is CH3COO minus acetate ion. So, acetic acid, acetate ion, they are common names. But IUPAC name, see, two carbons are there. Therefore, root word is eth, primary suffix is an, secondary suffix is oic acid, no prefix. Therefore, it will become ethanoate. So, to this if I attach Na, then it is called sodium acetate or sodium ethanoate. But in place of Na, I have methyl here. Therefore, it is common name is methyl acetate. And IUPAC name is methyl ethanoate. So, I told you, actually this is ester function group. See here. COO, C double bond O, this. I told you whenever COO is called ester and ester name ends with 8. But how? Always the alkyl group attached to oxygen is cation, the remaining is anion. Anion name is named according to IUPAC system. Just if you observe here, RCOO, suppose it is H. RCOH. It is general formula of carboxylic acids. So R means it may be meth, it may be eth, it may be prop, anything. That's why I will write alk, N, oic acid. Alkanoic acid is the IUPAC name of RCOOH. See, I am writing here RCOOH is, its IUPAC name is alkanoic acid. But in place of H, nothing is there, then it is called alkanoate ion. Now this alkanoate is attached to R. Then cation name is alkyl, anion name is alkanoate, then name becomes alkyl alkanoate. Then see here, this is H, this is aldehyde group, this is acid group, this is amide group, this is acyl halide group. aldehyde attached to H, acid attached to H, amide attached to H, acyl halide attached to H. Therefore, HCHO, common name I am telling, formaldehyde. Just now I told formaldehyde. Just now I told HCOH, formic acid, formamide, formyl chloride. HCHO, formaldehyde. HCOOH, formic acid. HCONH2, formamide. HCOCl, formyl chloride. These are common names. Then IPAC name. It is having only one carbon. All these root word is meth, and there are no side chains. Therefore, there are no prefixes. But when CHO is there, so all are meth. All are ane, because only one carbon, ane only. Methane, this is methane. But aldehyde group is there, second suffix is al. So therefore name becomes methanol. Acid group is there, second suffix becomes methanoic acid. Methanamide. Methanoyl chloride. Methanol. Methanoic acid. Methanamide. Methanoyl chloride. So, separately like see we can learn H, HCHO, formaldehyde, methanol. HCOOH, formic acid, methanoic acid. HCONH2, formamide, methanamide. HCOCl, formyl chloride. IPAC name is methanoyl chloride, like that. Then, just like that, this is aldehyde group. This is acid group. This is amide group. This is acyl halide or acyl chloride group. If aldehyde group is there, second suffix is al. If COH is there, second suffix is oic. If CONH2 is there, second suffix is amide. If COCl is there, second suffix is oil halide. So, suppose now I attach CH3. Single bond in the main chain. Therefore, ane-al, ane-oic, ane-amide, ane-oil halide. Now, two carbons are there in the main chain. Therefore, root word is ethanol, ethanoic, ane-amide, ethane-oil halide. Now, all these compounds, there are no side chains. Therefore, there will be no prefix. Therefore, no prefix. Like this, ethanol, ethanoic acid, ethanamide, ethanoyl halide. But here, CHO, COOH, CONH2, COCl, all I have attached hydrogen. Then it became form. Common names I am telling. Formaldehyde, formic acid, formamide, formyl chloride. Here when CH3 is there, we add acid, acetaldehyde, acetic acid, acetamide, acetyl chloride. These are common names. CH3CHO, acetaldehyde, CH3COH, acetic acid, CH3CONH2, acetamide, CH3COCl, acetyl chloride. So like this, we write the names. So like this, common names and IPAC names we'll come to know. So here now, already this I told, acetaldehyde, and IPAC name is ethanol. Already this I told, acetic acid. IPAC name is ethanoic acid. This is acetamide. IPAC name is ethanamide. This is acetyl bromide. IPAC name is ethanoyl bromide. So now coming to the 15th one. Here there are no side chains, only main chain. Main chain having how many carbons? 1, 2, 3 carbons. Therefore, root word is prop. Between all the 3 carbons, there is single bond only. Therefore, primary suffix is ane, propane. And there is a functional group, ketone functional group. When ketone functional group is there, then secondary suffix we write as -one. So propane -one. As there are no side chains, there will be no prefix. So complete name of this 15th compound is propanone. Now coming to this 19th compound. Here this is CO, ketone group. Here it is CONH2, this is amide group. Amide group is of high priority. Therefore it should get lowest number. 1, this is 2, this is 3, this is 4. So totally the main chain having how many carbons? 4 carbons. Therefore for this 19th compound, 19th answer I am writing here. Main chain having 1, 2, 3, 4 carbons, therefore root word is bute. Between all the carbons in the main chain, the bonds are single bonds. Therefore, primary suffix is ane. And high priority functional group is CONH2, it is called amide. Secondary suffix is amide. Now, at carbon 2, there is a methyl group. And at carbon 3, there is oxo. C double bond O, I told prefix is oxo. Now I am writing prefix now. Prefix. This is root word over, primary suffix over, secondary suffix over. Then prefix. Prefix is, in the alphabetical order, M comes first. So I will write 2-methyl, then 3-oxo. This is the prefix. Therefore, name of this compound becomes 2-methyl 3-oxo-butane amide. 19th compound. Then 20th. Simple compound, there are no side chains. 1, 2, 3, 4. So, bute 2-ene. Now, ane, it is not ane, it is ene now because there is a double bond. So, root word is bute. Primary suffix is 2-ene. There will be no secondary suffix and there will be no prefix. Name is just bute 2-ene. Sorry, bute 1-ene. Bute 1-ene. Now, this is 1, 2, 3, 4. This is bute 2-ene. So like this, 21 problems, their names I have written. Now 22nd question. He is asking you to write all possible structures of C4H8Cl2. C4 means I can write like this, C4. Cl2 means Cl and Cl I can attach like this. Then Cl and Cl I can attach like this. If I attach Cl and Cl to this is again this only. If I attach Cl and Cl to this is again this. Then Cl I will attach here, another Cl I will attach here. Then the same. Then one Cl here, one Cl here, another one. "25 minutes అయిందా? ఎంత అయింది? 2 నిమిషాలు. ఇంకా 2 నిమిషాలు ఉందా? Then C. So I can attach two Cls to this. I can attach two Cls to this, the same. Then one Cl to this, one Cl to this. Then one Cl to this, one Cl to this or this is the same. So these are possible structures of hydrogens. Anyhow remaining all we can write here, hydrogens here remaining we can see. Okay. Now common names first of all let us see. Whenever two halogen atoms are attached to same carbon, then common name becomes idine. Idine means what? This is butylidine chloride. Butylidine chloride. But when two chlorines are attached to adjacent carbons, then it is called ylene chloride. Butylene chloride. Now, this is one butylidine chloride, this is two butylidine chloride. Now coming to the IPAC names, this is 1,1 dichlorobutane, this is 1,2 dichlorobutane, this is 1,3 dichlorobutane, this is 2,2 dichlorobutane, then this is, now here this is the main chain. Probe is the root word, ane is the primary suffix, then 1, 2, 3, then it becomes 1,3 dichloro 2-methyl propane. Then this one, this is 1,1 dichloro 2-methyl propane. Then this is 1,2 dichloro 2-methyl propane. Like that, these are all different possible structures of C4H8Cl2 and their common names and their IPAC names. ఇంకేం అయిపోయాయి ఈరోజు చూద్దాం ఓపిక ఉంటే మళ్ళీ ఒకసారి ఒక గంట అయితే అయిపోయింది రికార్డ్